So students, we have just completed in the last lecture the area capacitance and the sidewall capacitance derivations. Okay, so we will write them over here once. So write down the formula for Cj0 over here once. Cj0, Cj0 will be square root of Q epsilon Si upon 2 phi naught Na Nd divided by Na plus Nd. Okay, this is farad per centimeter square. Alright, yes. And K equivalent term, what is the formula? K equivalent term is, I'm just writing for the reference, 2 phi naught V2 minus V1 square root of 1 minus V2 upon phi naught minus square root of 1 minus V1 upon phi naught. And for sidewall, the doping of Na will be Na sidewall, which is higher doping. It doesn't have any unit, it falls between 0 to 1 value, K equivalent. And area and perimeter, well, it changes from capacitance to capacitance. Which capacitance we are talking about, according to that we will change. Alright, so we are ready to solve the first numerical. So let me adjust this PDF so that I can view the numerical statement, and here I can solve it simultaneously. So let's start. I'll read down the numerical statement. This numerical number 1 and MOSFET capacitance. So I'll only write the given data. And abrupt PN junction is reverse bias. So we have abrupt PN junction reverse bias. The doping density of N-type region. So what is N-type region doping called as? Nd, right? It's 10 raised to 19 per centimeter cube. Please write down along. Doping density of P-type region is how much? 16. So Na is 10 raised to 16 per centimeter cube. The area, the junction area is 20 micrometer into 20 micrometer. So area is given 20 micrometer into 20 micrometer multiplied. So this will be 400 into 10 raised to minus 6 meters. I mean 10 raised to minus 12. Sorry. Minus 12 meter square. So if I want to convert into centimeter, it will be 400 into 10 raised to minus 8 centimeter square. Okay, because 100 centimeter is 1 meter, that's why we can write this. Alright, so what all things we have to find out? We have to find out the following. So let me write what we need to find out. To find zero bias junction capacitance, so we have to find over here Cj0. Okay, first we have to find Cj0, then total junction capacitance at reverse voltage of 5 volt. So Cj of 5 volt we have to find out. Then equivalent large junction capacitance if the reverse voltage changes from 0 to minus 5. So third thing we have to find is Cj equivalent. Alright, so when the reverse voltage is changing from 0 to minus 5. So Cj equivalent we have to find out. So let's start with the numerical. Now this is the given data. So here at reverse voltage, reverse bias voltage is how much over here? 5 volt. So that means minus 5 only. And large signal junction capacitance we have to find out the value. Cj equivalent when the reverse voltage is changing from 0 to minus 5. So we have written the data over here. Let's concentrate on finding the numerical. Okay, so we must know few constant values. So which are the constant values? We'll write down over here. Before proceeding ahead, we should know some constants. These constants are, we'll write down, assume epsilon for epsilon of silicon will be 10 raised to minus 12, basically 11.7, right, into 8.854 into 10 raised to minus 14, which comes to be 10 raised to minus 12 only. Then Ni square, how much is Ni square? Anyone? 2.1 into 10 raised to 20 per centimeter cube. And what is kT by Q? 26 millivolt. Agree? So can we start now? Let's start with the solution. Keep your calculators in handy. So first we'll find out phi naught. So phi naught is kT by Q natural log of NA upon Ni square. So kT by Q is 26 millivolts. So 26 into 10 raised to minus 3 into natural log of Na. Na is 10 raised to 16 into Nd is 10 raised to 19 divided by 2.1 into 10 raised to 20. So calculate and let me know what is the answer for phi naught. Phi naught is the building potential. You have to let me know this answer. So carefully let me know this answer, please. Remember it is Ni square. So Ni square is 2.1 into 10 raised to 20. Remember that. Ni was 1.45 into 10 raised to 10. Anyone with the answer? No. No. Answer is wrong. Not 3.21. It's less than 1. Yes, 0.879, right? Okay, yeah, this is correct. So please, those who got the answer 3 point something, please check. Built-in potential is always less than 1. Very, very much. So once we have found built-in potential phi naught, we find Cj0. Zero bias junction capacitance, which is given by the formula 2 epsilon for silicon divided by Q into, oh, not Q, Q actually, here Q will come. Q epsilon for silicon upon twice phi naught Na divided by Na plus Nd. Okay, so substitute all the values. Cj0 is square root of Q is 1.6 into 10 raised to minus 19. Epsilon silicon is 10 raised to minus 12. This to 2 into 0.879. NAND will be 10 raised to 19 into 10 raised to 16 divided by 10 raised to 19 plus 10 raised to 16. So calculate this number and let me know the answer. This will be in nanofarad per centimeter square. And this is called as zero bias junction capacitance. So let me know the value once you get it. How much it is? Anyone? Cj0 unit is farad per centimeter square, but I wanted nanofarad per centimeter square. How much it is coming? 30.15. Yes, that's correct. 30 nanofarad per centimeter square. That's correct. So now we go for the third part. So Cj0 is this. Third part is Cj of V. We have to find reverse bias. So this A into, what is the formula? A into Cj0 divided by 1 minus V upon phi naught raised to M. Now M over here is half because it is an abrupt PN junction. It's given. Okay, M is half. Cj0 is given. How much is area? 400 into 10 is to minus 8. Okay, phi naught we already have. Phi naught was how much? 0.879, and Cj0 value is also available. So please substitute this formula over here. and calculate the value. So I'll write it down. Cj of V will be area, which is 400 into 10 is to minus 8. Cj0 we got it as 30.15 nano, 10 is to minus 9, and this will be 1 minus, what is V voltage given by? Minus 5, right? Because it's a reverse bias voltage. So reverse bias voltage of 5 volt, that means it is minus 5. So it is minus 5 divided by 0.879, the whole raised to half. So calculate this number, please. So Cj of V will be, this multiplication in the numerator is 120.6 into 10 is to minus 15, and in the denominator we get around 2.586. So calculate Cj of V at, so it's coming out to be how much? How many farad? Tell me the number along with the unit. So this 1 minus minus becomes plus, raised to half. So this is called as junction capacitance at reverse bias voltage of 5 volt. Alright. How much is the value? Quickly tell. Evaluate this and let me know what you get in the calculator. What is the answer? 14, right? 4.6. So you write in terms of minus 15. So 46.6 into 10 is to minus 15. Do you know what is 10 is to minus 15? Femtofarad. Femto. 10 is to minus 9 is nano, 10 is to minus 12 is pico, 10 is to minus 15 is femtofarad. Alright. So this is the junction capacitance at a reverse voltage of 5 volt. Now we go to the next part. Quickly we have to do it, we have less time. 4. So reverse voltage is changing from 0 volt to minus 5. So there is a switching involved. That means we have to calculate K equivalent. When the voltage is switching, the earlier one it was only 5 volts. Now it is switching 0 to minus 5. So K equivalent will be minus 2 phi naught upon V2 minus V1 into square root of 1 minus V2 upon phi naught. We know its value will come between 0 and 1. This K equivalent 1 minus V1 upon phi naught. To substitute the values over here, so K equivalent will be minus twice phi naught value is 0.879 we have calculated. V2 minus V1, it is minus 5 minus 0, so minus 5 only. So here you will get it as 1 minus V2 is minus 5, so it will be plus 5 divided by 0.879. Here this value is 0. Okay, so really multiplication of this. So tell me what is K equivalent? Quickly. Its value will be between 0 and 1. So this number will be 0.3516. This number will be 2.586 minus 1. So how much is this K equivalent? Always you need to check, it will be between 0 and 1. K equivalent number. Anyone with the answer? It's a dimensionless quantity. Yes, 0.557. Absolutely correct. Now we have to find out equivalent large signal junction capacitance. That is, next will be Cj equivalent of V. And what is the formula? A into Cj0 into K equivalent. Okay? And how much it is? Cj equivalent. A is 400 into 10 is to minus 8. Cj0 is 30.15 into 10 is to minus 9, and K equivalent is 0.557. So just the multiplication of these three terms and let me know the answer. How much is the answer in farads? This is the last answer for this numerical, and we have one more numerical to go. How much it is? Yes. So basically this capacitance is 67.17 femtofarad. Okay, so this is the way we can use all the formulas to calculate. But this was the easy part. Now the tough part is the next numerical which is coming up, which is very, very crucial. Okay, so that numerical, since it is very long, I will describe that. Describe in the sense, will not write that numerical, you go through it, and yeah, if you have any doubt in that, we will then write it down. So what do you suggest? We should solve it like this, or I will just show it to you the solution? You tell me. It will be good and it will save time. Okay, fine. I'll do that. Okay. So next is, this is the numerical. And this is the numerical form which might come in the exam in this manner. In this form, it will come. So let's concentrate on this. Consider N-channel enhancement type MOSFET top U. This is my N-channel enhancement type MOSFET top U. The process parameters are as follows. Substrate doping is given Na. Source drain doping is given as Nd. Sidewall doping is given as Na sidewall. Gate oxide thickness is Tox 45 nanometer. So it will be 45 into 10 is to minus 9 meters. That will be 45 into 10 is to minus 7 centimeter. Xj is 1 micrometer. So that means 10 is to minus 4 centimeter. Alright? Correct? And we have this drain to source, drain region and source region, N plus diffusion layers. This is phi. This is channel width, right? W. So W is phi. Can you tell me what is this? How much is this? 2 micrometer. Okay. This is 10 micrometer. So you know what is this? Channel length. This is not channel length. This is Y. Remember? Diffusion region length is Y. Okay. And this overlap area is 2 micrometer. So we have been given, note that source and drain diffusion regions are surrounded by P plus channel stop diffusion. The substrate is biased at 0 volt, assuming that drain voltage is changing from 0.5 to 5 volt. Okay, so this is V1, this is V2. Find the average drain substrate junction capacitance. Okay, so drain to substrate, so we have to find C, D, B, J. That can be sidewall also, right? So we can also find C, S, W, D, J. So we might have to find this one, average drain substrate junction capacitance. So can we start? So as per the top view, three sidewall capacitances of drain diffusion region form the N plus junction. Okay, which one? This one, this one, and this one. We are not drawing, total. So these are the three junctions which is facing the channel stop implant. Yes or no? 1, 2, 3. I have not drawn it in the 2D manner, but this is what happens. The bottom and the side wall. What are the bottom and the side wall? The side wall is number 4 and the bottom is 5. This is 1, 2, 3. So 1, 2, 3 and 4 are side wall, 5 is bottom. Agree? Yes or no? So the three side wall of drain diffusion region is forming N plus P plus junction. And bottom and the side wall, that is 4 and 5 are forming the N plus P junction. Remember that. Okay. So here the doping of substrate will be Na. Here the doping of substrate will be Na side wall. Because here the junction is P plus N plus. Here the junction is P N plus. Okay. So first we'll find out the built-in potential given by the formula KT by Q ln of Na Nd upon Ni square. So we got it as 0.873. Then we'll again find the built-in potential for side wall also. Okay. So we'll find phi naught and phi naught SW, because we will require the side wall built-in potential also. So here what is the difference? Side wall doping will be substituted. So here is the side wall doping. Side wall doping is given as 4 into 10 is to 16. So you have to substitute this. So side wall doping is 4 into 10 is to 16. We get a higher value of built-in potential for side wall, 0.917 volt. Got it? So I hope you will be solving this on your own, at your own end, in your books, and getting the answers similar to this. Right now I am just describing. Then we'll find CJ0 and CJ0 side wall. 0 bias junction capacitance. So here it is the formula, square root of Q epsilon silicon upon 2 phi naught Na Nd upon Na plus Nd. So here you will get it around, the value is around 14.1. Here let me write the value. This is around 0.837 volt, 0.915 volt. You should get these answers. CJ0 will be 14.1 nanofarad per centimeter square, and CJ's 0 side wall, yeah, side wall doping will be substituted. Phi naught side wall will be substituted. So here it is wrong actually. It will be how much? 0.915. Okay, so here there is one change. So calculate the new number here, because here it was substituted wrong. So it will be somewhere close to 60 point something, right? Let's say 61 nanofarad per centimeter square. Actually it will be lesser because it will be higher. It is in the denominator. So around, let's say around 60. Close to 60 it will be. 60 nanofarad per centimeter square. Then we find out the junction capacitance at side wall. So Cj side wall is given by Cj SW into Xj. We have written this before, right? So it will be Cj0 side wall, which is around 60, multiplied by Xj. The Xj is how much? 10 is to minus 4. Junction depth is 10 is to minus 4. See? So multiply it with 10 is to minus 4. So you will get it as 6.6 picofarad per centimeter. Okay? 6 into 10 is to minus 12 farad per centimeter. So 6 picofarad. So we get Cj side wall. Now in order to take care, in order that the given drain voltage variation into account, we must now calculate K equivalent and K equivalent sidewall for both the types of junction. So this will allow the voltage to go from, it's a negative voltage, right? So it will go from minus 0.5 to minus 5. So you need to calculate K equivalent, where V1 is minus 0.5 and V2 is minus 5. Okay, so K equivalent is minus 2 phi naught. Just now we have calculated V2 minus V1, square root of 1 minus V2 upon phi naught minus 1 upon square root of 1 minus V1 upon phi naught. So substitute this value, this will become plus phi, and here this will become also plus phi, right? Yeah, minus 0.5. So you substitute the values over here, what you will get it as 0.51. Similarly, you substitute the values for K equivalent for sidewall. So here you will substitute 0.915, 0.915. Here you will substitute minus. It's going from zero point 0.5, right? 0.5 volts. Drain voltage is changing from 0.5 to 0. Substrate is 0. So yeah, it will be minus 0.5 only. Correct, it is. So here it will be, here the value will come out to be 0.53. So really K equivalent and K equivalent SW is not changing much. Now the total area of P silicon and N plus junction is, what is the area associated with this? 4 and 5, right? 4 and 5, that means this. So if you have, let me go back over here. This is 1, 2 and 3 is sidewall capacitance. 4 and 5 is the bottom capacitance, right? So 4 and 5. So the area will be how much? Let me draw that. This is drain region, right? 5 into 10 micrometer. So this is 5 into 10. So this is N plus drain region, right? So here we can write down, this is N plus drain. This is 5 micrometer. This is 10 micrometer. Yes or no? So area will be 10 into 5. And here the overlap, the gate overlap is how much? The gate is overlapping, right? Here this one. So this is given as 2 micrometer. And this is also 1. So this area will be 1. Almost like this overlap will be around, let's say, this junction depth will be around 1. So it will be 10 into 5, 5 into 1 plus 5 into 1. Why 5 into 1? 5 into 10. This is for what? This is for which junction? This is 1, 2, 3. This is 4. This is 5. For the fifth one. For the fifth one, how much it is? 5 into 10. The area is 5 into 10. You remember you have written this W into Y, correct? In the table form. So W into Y. Now it will be W into 1. This much only area. So let's say this is 1. So W into 1. This is, then we have to calculate this area. Area is coming out to be 55 into 10 is to minus 8 centimeter square. Okay. Now we have to calculate total length of N plus P plus perimeter. So what is the total length over here? Total length is this. This is the perimeter, the yellow region, which I am drawing over here. This one. So what is the perimeter? Perimeter is 2y plus w, right? So how much is 2y? Y over here is 10. And this is w. So perimeter is 25 micrometer. So perimeter is 25 into 10 is to minus 4 centimeter. Okay. Now we have to find the value of C, D, B, J. So what is the formula? A into Cj is 0 into K equivalent. Area is 55. Cj 0 we have found out. K equivalent we found out. So this comes out to be 3.95 femtofarad. Now we have to find out C, SW, BJ, DJ actually. C sidewall drain to substrate bias. So it will be given by perimeter into S sidewall, Cj sidewall into K equivalent of sidewall. This comes out to be 7.963 femtofarad. So sidewall capacitance is, the value is slightly greater than what we initially get. So this is also in farad, this is also in farad. So what will be the average combined? So what will be CDB? Okay, drain to substrate capacitance will be CDBJ plus CSWDBJ, and that comes out to be around 11.91 femtofarad. Alright, so in this way they can ask you such numericals, and they can ask you to find out the drain to substrate capacitance or source to substrate capacitance. Basically drain to substrate capacitance is the one which will involve switching. Okay, so they can even ask you something like this. Let me show it to you. They can even ask you to find out CSJ SBJ. Okay, so that time it will be A into CJ0, no need to find K equivalent. So here we have found out what we have found out, CDBJ. Okay, junction plus CSW, so sidewall plus area capacitance we have found out, and we got the answer as 11.91. Alright, so the thing which is left up to you is you need to substitute the values in the formulas and verify all the terms. There is one correction over here. The correction I've already told you. Here instead of 2 into, we have substituted phi naught, here we have to substitute phi naught SW. So do that correction, find out the new value and plug in those values only. Alright, so yeah, so that's it for this lecture. So we have completed your topic of MOSFET capacitance. Next time we'll start with scaling. Okay, so that's all for today.